Hello everyone. In this course, I'm going to discuss about the three-phase induction motor. Three-phase induction motor is also known as asynchronous machines. This course is useful for fourth semester electrical machine 2. In this module, we will be going to study mainly about the AC machines. So, three-phase induction motor. Then we will study about the asynchronous machine. Then after that, we will study about the synchronous generators. So in this chapter, the contents are facts about induction motor, application of the induction motor. Then we will see construction of the induction motor, how induction motor are constructed. Rotating magnetic field, what are the effects on the rotating magnetic field that we have to study. Principle of operation of the induction motor. Then we will see its equivalent circuit. It is similar. There are a lot of similarities between the equivalent circuit of induction machine with the transformer that we have to study. Performance characteristics, then a starting method, and a speed control. These are the main topic which we have to study in this course. So first about facts about the induction motor. So the facts about induction motor is that AC machines, if you see here, AC machines, this AC machine has two parts. One is called synchronous machine, another is called induction machine. And the major difference between a synchronous machine and induction machine is that magnetic field current is supplied by separate DC power supply. In case of synchronous machine, we are giving to the in the rotor. Suppose this is rotor, and this is our stator part. So this rotor part is given separate DC supply is being given to this rotor circuit, and this rotor is being rotated at a speed. That speed is called synchronous speed. Separate supply is given. DC supply is given. But for the case of induction machine, it is induced by the principle of induction, and it is taken from the stator. There is no need to give extra supply to the rotor side. Field current is supplied by magnetic induction into their field winding. Through magnetic induction, here suppose a stator is being given three-phase supply, and through the induction principle, here the rotor has got magnetic field, but here separate supply is being given. This is the one of the biggest difference between the synchronous machine and induction machine. So this part is the some historical background of the facts about induction motor. That in 1882, Nikola Tesla discovered the rotating magnetic field, a fundamental principle in physics and one of the greatest discoveries of all the time. This is the fundamental principle and one of the greatest discovery of all the time. Tesla AC induction motor is one of the 10 greatest discover of all time. This is very fact thing that Tesla has discovered this machine in 1882, and this is in fact it is the 10th greatest discover of all the time. Nowadays, about 65% of electric energy in the United States is consumed by electric motors. 65% energy in the United States is consumed by electric motors, and in industrial sector alone, about 75% is consumed by motor, and over 90% of them are induction in nature. Means ki 75% motors are motors in an industrial application. 75% are motor. And in these 75%, over 90% applications are in industrial applications are induction in nature. So that is why we have to understand the basic fundamental principle and how it is going to operate a three-phase induction motor, that we have to study in detail. Why induction motors are popular? Now question is, why induction motors are so much popular? as compared to the DC machines. The induction motors are popular because they are rugged, means they are very they can take a load, and they can operate in a very dirty condition also, like a smoke and humid condition they can operate. Reliable, they are reliable also. Induction motors are, their reliability is high. Easy to maintain, its maintenance is also very easy. We can maintain its performance very easily. Relatively inexpensive, it's not too much expensive as in case of the DC machine. Every time we need to replace its brushes, so that machine is expensive. Here there is a no need or no need to replace the brushes, because there is a no brush available at all. Their power to density ratio, output power to weight, are higher than some other motors. Means their output power to weight, means output power we are getting more as compared to the weight. So these are the some things that makes the induction motor more popular. Now some applications I am going to give. A small single-phase induction motors are used in many household applications such as blenders, juice mixers, washing machine, refrigerator, etc. Small machines are being used here. A small single-phase induction motors that are we are also using this induction motor in our home applications, like juice blenders, mixers, washing machine, etc. We are using in our home this type of machines, single phase induction motors. Large three-phase induction motors are used in traction vehicle, lift, pumps, fans, compressor, paper mills, etc. So these two are the very common applications of the induction motors, and these two are found in industrial applications, refrigerators and traction vehicles, lifts, pump, where we find three-phase induction motor applications. This is also an showing an application that is in ocean, the high-speed dolphin flying. Here, induction motors are used to run this high-speed dolphins. These are also application like in case of the railway. Here also it is electric bus. Here we are also in metro. Also these are the applications of the electrical induction motor. Here it is a lift. Here induction motors are used. As accelerator is there. This is a lift, car, and electric vehicle. Also induction motors are being used. Let's see some fundamental concept how it is made. Construction is simple as compared to the DC machines. Here the terminal box is given. Here three-phase supply is being given. Here cooling fan is provided. This portion is rotor side, and this is the shaft position. This is stator winding is placed here, and three-phase supply is given here. And this stator, in fact, this stator creates three-phase rotating magnetic field. This is stator. Here, this is stator. This stator winding, when three-phase supply is given, then here three-phase rotating magnetic fields are produced, and this magnetic rotating field interact with the rotor conductors, rotor bars. In fact, here heavy bars are placed in the slots, and induced EMF is produced here, and rotating torque is produced here. So through induction here, there is no separate need of the supply given to this rotating part. As in case of synchronous machine, we have to supply extra DC supply to create the magnetic field. So this is induction motor. A schematic diagram is given here. In this case, we can see very easily that three-phase supply is given to the stator. As here in a stator side, three-phase supply is given, and this three-phase supply, a stator winding is given here, rotor winding is there, and the rotor winding also, it is a three-phase supply, three-phase rotor winding is there, and three-phase stator. This connection is, in fact, this is a stator winding, and it is connected in a star. So a schematic diagram of a squirrel cage induction motor. Basically, there are two types of rotors are there that we will see later. So here in induction motors, a schematic diagram of a squirrel cage induction motor is given here. So in this side, we can see very easily three-phase stator supply here, phase A, phase B, and phase C are given, and there is an air gap. This air gap is present between rotor and a stator, and this rotor is here. Rotor is three-phase rotor is given here, and in this case also here a stator winding is there, and slip rings, brushes, external variable resistance are provided here. So these are the some very fundamental, very basic things that is shown here. A schematic diagram, wound rotor, induction motor. In case induction motors have two types of induction motor having we have encountered with the rotor. One is called a squirrel cage rotor, and another is that is here slip ring induction motor. Construction. So some detailed construction here. A stator, a three-phase winding is put in the slots cut on the inner surface of the stationary part. The end of these winding can be connected in a star or in delta to form a three-phase connection. These windings are fed from three-phase AC supply. So here you see here from the construction point of view, these are the slots. Here windings are plates, these are the teeths, and here three-phase supply is given. This is the cut view shown here. These are the slots available in the stator side where conductors are placed. And these windings are fed from three-phase AC supply. Like that, its equivalent circuit is shown here. Three-phase line are coming here, and 14 volt is given. Line current is shown here. For example, it is 10 ampere taken here. Torque and input power of a single of a induction motor. So this is the stator point of view. Here a stator cut view is shown. Here slots are there, and windings are placed in these slots. And when three-phase supply is given, what will happen? A rotating magnetic field is produced, and if a rotor is placed here, then this rotating magnetic field will induce EMF in the rotor, and the tendency of rotor EMF will be to oppose the cause which produces it. So the flux which produces it, the tendency is to oppose it. Means whatever direction of the rotating magnetic field is that, so opposition is possible only when the rotor will start to run in the same direction. If it start running in the same direction, suppose that I'm giving here view example that suppose our rotating stator magnetic field is running in this direction, then rotor also will start to run in the same direction to oppose the cause produced by it. If it run in the same direction, their relative velocity will be decreased. Suppose it is running at 1000 rpm, just an example I'm taking, 1000 rpm. So this rotor MMF, this rotor will also want to run at the same speed. So in the same direction it will start to run, but once when it reaches at the 1000 rpm, the induced EMF at the rotor becomes zero. That is why the rotor of the induction motor is never allowed to run at the synchronous speed. If it reaches that synchronous speed, the induced EMF in the rotor will be zero. So to avoid the induced EMF becomes zero in the rotor, the speed of the rotor is kept always not equal to the rotating magnetic field speed, but it is very near to the rotating magnetic field, but never equal to. Once it becomes equal to the rotating magnetic field, what will happen? The induced EMF in the rotor becomes zero, and torque also becomes zero. So machine momentarily will slow down And once when it slow down, again there will be a relative speed between the stator mmf and rotor, so machine again will start to catch this speed. So in this way the speed reaches 1000, then come down, like that there will be a jerking, so the machine life will be in trouble. So we have to design in such a way that the rotor, that the rotor of the induction motor should never reach at the 1000 rpm, or the speed at which the machine is stator mmf is running. And whatever a stator mmf speed is there, that speed is called synchronous speed, and its value is given by 120 f by p. So synchronous speed is that speed at which the stator, when this stator is given, suppose three phase supply is given here, this stator mmf starts running at a speed, and this resultant speed is nothing but it is called a synchronous speed. So later part we will see in the next video.